Hey class, welcome back. We're making lesson 5 now. It's going to be lesson 5, making connections, graphs, equations, words. Right, so what we're going to start off by doing is we're going to be talking about direct and partial variations. So before we even get started, we're going to go over these two different parties, or the cost to go to a party at two different locations. So the cost to go to a party at the first location is represented by this table of values. So if there's no people, the cost will cost nothing. If there's 10 people, if there's 10 people, then it'll cost $400, 20, it'll cost 800, blah, 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 blah. So if you look at this variation right now, I'm just going to go and put this over. So if you look at this graph, you'll notice that the rise over run rate is going to be, if you go up, the rise is 0 to about 400, and the run is 10. So 400 over 10, right? Our slope is equal to rise over run equals 400 over 10, right? Which is equal to 40. So it's safe to say that our cost is going up by 40 each time, right? Yep, 10, 40, 20 times 40 equals 800, 30 times 40 equals 1200, 40 times 40 equals 1600, 50 times 40 equals 1000. Alright, so equation for this could easily be y equals 40x. 40 times x will give me y. What if I went over here? Right? Here we're starting off with 100. So that means that whatever I do, I gotta add 100 at the end. So y is going to give me some number, some slope, x, plus 100. I can simply find the slope. By going back to my chart down here, I'm going to go rise over run. So I'm going from 200 to 400, which means that, it's 100. 100, because if you look in, I'm just going to zoom in, you're actually here. So 100 to 400. So my rise is 300. My run is still 10. So if I'm going to find my slope, it's going to be m equals rise, which is 300, over run equals 30 over 10 equals 30. Apologies. Equals 30. Let's go back and see if that makes sense. Y equals 30x plus 100. Does that make sense? Because if I did 10 times 30, 10 times 30 is 300, plus 100 is 400. 20 times 30 is 600, plus 100 is 700. 30 times 30 is 900, plus 100 is 1000. So it makes sense. That equation makes sense in that situation. So what it's telling us to do is for each ordered pair, and let's just go in and put in these ordered pairs, right? Let's just go do what it's doing. It says for each ordered pair, divide the y value by the x value. So let's find this. So let's go to the 400, divide it by 10, I'll get 40. 800 divided by 20, I'll get 40. 1200 divided by 30, I'll get 40. 1600 divided by 40, I'll get 30. 2000 divided by 50, and I will get 40. So I can just write that in. I just did it on my calculator, but for the sake of clarity, let's just write it in. So I'm just going to go up and I'm going to say 0 divided by 0 is just 0. Let's just start off at 400 divided by 10, 40, 800 divided by 20, 40, 1200 divided by 30 equals 40, 1600 divided by 40 equals 40, and last but not least, 2000 divided by 50 equals 40. So what do you notice? All the values of delta, or of y divided by x, are constant at 40. Okay. So now let's try doing the same thing with our values over here. So I'm just going to redraw my table of values. Sorry guys. X, Y, and then this will be a little bit neater. So we'll do 0 divided by 100 is just 0. 100 divided by 0 is just 0. Or undefined, right? I'm just going to write that as not defined. You can't divide a number by 0. Right? Let's do the 400 divided by 10, 40. 700 divided by 20, 35. 30 and 1000, so 1000 divided by 30. 33. Sorry guys, 33.33. I'm going to make another chart over here just to continue. Sorry about that. So I'm just going to do 40 and 1300. 1300 divided by 40. 32.5. And then last but not least, 1600 divided by 50. And that gave me 32. So what do we notice here? All the values for y over x are not constant. Alright, so we're just going to go on and we're going to do a little bit of summary of direct and partial variation. So I'm going to just give you a really quick kind of summary of what the difference between these two are. So if we're going to look at even these two, right, this is what we call a direct variation. And that's because any change in x is directly coming from the slope. This is considered a partial variation. And that's because you have a slope, you have some change coming from the slope, but you also have that initial 100, which kind of skews the data. So what happens here is that you have not a constant rate of change, or what's looking like it's not a constant rate of change. It's looking like when you divide the x and the y, they're not constant, or the y and the x, they're not constant. Okay, so a direct variation has 0, 0 as an ordered pair. That means that at some point, ordered pair on the table of values. That means at some point that graph crosses through the origin. The initial value is 0. Sorry guys, I'm really apologetic. I don't know what's in my throat. The initial value is 0. So the graph itself, and I said this already, graph passes through and the equation for this often looks like y equals mx, where y represents the y value and m is the slope. Okay, so m represents slope. We talked about that yesterday, or this morning, or in our last lesson, sorry. Right, So partial variation, on the other hand, 0, 0 actually doesn't exist on that graph. So if you look back here, right, there's no 0, 0 value. If this was to keep going, you would never cross the origin. So 0, 0 is not an ordered pair. Right? The initial value or the value at which this crosses through the y-intercept is some number b. Some number b. And b is important. So the graph, when it intercepts with the y-axis, right, which is why we call it the y-intercept, because this is the one it's meeting the y-axis. It's meeting here. When it intercepts the y-axis, the graph passes through zero and b. So the equation looks like y equals mx plus that initial cross through, because it seems to be shifted up a little bit. Okay? So if we're given a relationship that is a direct variation, it's not going to have that b value. So we can just find out what the slope is by saying, okay, let's do y divided by x. So we can determine the constant of the variation. You can determine the constant. Or the slope by doing y divided by x. So in this situation, we can just do 18 divided by 6 equals 3. Right? So this is going to go up by 3 each time. So determine the equation of the relation. It's just going to be y equals 3x. So let's just complete this table. Let's just go in and say, all right, y is equal to 3x and x is 4. Y is equal to 3 times 4, 12, 15. 7 times 3 is 21. 8 times 3 is 24. 27. Another way we could figure this out, this seems to be increasing by 3 each time. You're just adding 3. Okay? So we completed the table. If y varies directly as x, which is the same thing as saying this is a direct variation, and y is 36 and x is 9, determine the value of y when x is 4. So first things first, let's figure out the constant. Or the slope. So I know my slope is y over x. So I'm going to do, what's my y value? 36 divided by x, which was 9. So I know my slope is 3, right? So if my slope is 3, right, because I'm doing my constant, so we won't even do, we'll say constant, because that might confuse some people. My constant is 3. That means that my slope notation is y equals 3x. So let's just do y equals 3 times 4 equals 12. Okay? Now this is where it starts to get a little bit tricky because now we're using word problems. So it says Melissa works in a store and earns 8% commission on her sales. And on top of that, she makes a $350 a week salary. So is this a direct or a partial variation? It's a partial variation. And that is because she'll never make $0, right? She'll always at least make $350 even if she sells nothing the entire week, right? It's a partial variation because the graph itself will start at, even if she makes no sales, will start at 0 and 350. Because even if she makes no sales, she'll at least make $350 a week. So let's figure out the equation for the situation. So if I know it's 0 and 350, I know it's going to be 350 at the end. Y equals. Let's define our variables first. Oops, sorry. Let's just go in and define our variables. So I'm going to say Y equals the amount of money she makes. Money made per week. X is going to be the sales that she makes. So the dollars in sales that she makes, right? And then my B value is going to be her weekly salary. I know that my B is going to be 350, so I'm going to add that at the end. Y is what I'm looking for. X is what my weekly sales are going to be. How do I know how much is going to go up by every time she makes a sale? It says she earns some amount of commission on each of her sales. 8%, right? So she earns 8% of commission on each of her sales. So we're going to put the 8% in front of the X. It's going to go up by 8% every time she makes a sale. So I have Y equals 0.08X plus 350. That's my equation, right? So if that's my equation, I'm just going to make this into a color that everyone can see. If that's my equation, right? So I'm going to write Y equals 0.08X plus 350. If she makes $5,000 worth of furniture sales, right? How much will she earn? So I know Y is how much she's making, so that's going to be empty. 0.08. X represents how much money she made in sales. So I'm going to plug in the 5,000 plus 350. So right off the bat, I'm going to go in and I'm going to say, okay, what's 0.08? So 8% of 5,000 is going to be 400, right? So she'll make $400 in commission plus the $350 she's making regardless. So altogether, she'll have made $750 a week. So Y will equal 750. Therefore, Melissa will make $750 this week. Or that week, or whatever you want to write. Okay? So, what we're going to do is we're actually going to be doing a little bit